Okay, class, we're about to go over sections 113 and 114. Now, let me share my screen here. Okay, now, if you notice here, I'm not putting the textbook up anymore because all of you should have the textbook by now. I am putting up the problems. So we're on 1.13, 1.14 on pages 130 to 132. And then I have the problems listed out here, and this is coming directly from JetNet. All right, so the problems I'm going to do, because I don't want to do problems that are too easy. So what I'm going to do, I would do problems 3, 5, and 6. Yeah, I think that would actually work. Okay, so let's go. Well, let me do 3. Okay, problem number 3. We had x plus 2y minus z equals 0. 3x plus 2y plus z is equal to negative 8. And 2x plus 3y plus z equals 0. Now, what we're supposed to do, we're supposed to try and get rid of one of the variables if we can. If you notice here, we have a good candidate with these z's, the negative z and the positive z. So I'm going to take these first two equations and add them together, and these z's will simplify out. So this would be 4x plus 4y equals negative 8. Okay, now I would take this top equation again and go with the bottom equation. So I would have x plus 2y minus z equals 0, 2x plus 3y plus z equals 0. So this would be 3x plus 5y, the z's will go, equals 0. So we had 3x plus 5y equals 0. Now we're supposed to solve for x and y. So we have to determine which variable we want to get rid of. Let's say that we want to get rid of the y values. Now, if you notice here with the y's, both of these signs are positive. So that means that when we multiply to get them to have a common multiple, we have to multiply at least one of these equations by a negative number whenever you have the same sign, whether it be two addition signs or two subtraction signs. So the common multiple of 4 and 5, one of them is 20. So we know we have to multiply the top by 5 and the bottom by 4. Now it doesn't matter which one of these that you make negative, I'll do the bottom. So it'll be 20x plus 20y equals negative 40. That took care of the top equation. Now the bottom equation, it'll be negative 12x minus 20y is equal to 0. 20x minus 12x is 8x. The y's will simplify out and equals negative 40. Divide each side by 8 and x equals negative 5. Now that we have x equals negative 5, we could go back to one of these two equations here to find y. So I will go with the top equation. So we have 4 times negative 5 plus 4y is equal to a negative 8. So this would be a negative 20 plus 4y equals negative 8. We'll add 20 on both sides, and 4y is equal to 12. We'll divide each side by 4, and y is equal to 3. So now we have x is negative 5 and y is 3. Now all we have to do is find z. Now to find z, we will go back up here to one of these three original equations. I will do the top. So I have x plus 2y minus z equals 0. Now I substitute in the values for x and y. So it'd be negative 5 plus 2 times y is 3 minus z equals 0. So this would be negative 5 plus 6 minus z equals 0. Negative 5 plus 6 is 1. 1 minus z equals 0. We'll subtract 1 on both sides. Negative z equals negative 1. Divide each side by negative 1, and z is 1. So now our final answer, we will write it as an ordered triple. So we'll have the x would go first, would be negative 5, the y would be 3, and the z would be 1. And that would be your final answer. And then you could go through and test to make sure that this answer is correct. Does everyone follow that?
Yes.
Okay. All right, now, number 5. The reason why I'm actually doing number 5 is because some of the final answers are a little unique. So it's still the same process, but let me do 5A so you can see what I'm talking about here. All right, this is 5A. Now we do this the same way we did the other problems. The first thing we want to do is to get rid of one of the variables. It looks like y here is a good candidate. So I would do these two equations, the middle two, well, the middle and the last. Add them together. This would be 5x. The y's will go plus 7z is equal to 8. Now, I could take this second equation here and go to the first one now. So you add x plus 2y plus z equals 4. And then you add 2x minus y plus 3z equals 2. So we're going to get rid of the y's because we want the same type of equation here. So if we look at the y's here, they have opposite signs, and their least their common multiple is 2. A lot of people would say least common multiple, but a common multiple will work as well. So here we would do 2, so we'll multiply the bottom here by 2. The top equation will stay the same, and this would be 4x minus 2y minus 6z, well actually I'm sorry, plus 6z is equal to 4. So this would give us 5x, these will go, this would be plus 7z is equal to 8. So we have 5x plus 7z is equal to 8. Now, if you look here, we have the exact same formulas here, the exact same equations. Whenever you have this situation, this means that it's dependent and it's infinite solutions. Now, but let's say that you didn't recognize that when you were doing this. So let's show an example of what would happen. So let's say you're not paying attention and you're like, okay, I'm going to get rid of the z's here. So you look here and you're like, okay, I'm going to multiply the bottom equation by negative 1 because all I need to do is just change the sign. So you have 5x plus 7z is equal to 8. And then the bottom would be negative 5x minus 7z is equal to negative 8. When everything simplifies out over here, that just leaves you with 0. And 8 minus 8 is 0. So if you get 0 equals 0, or 5 equals 5, or 1 equals 1, a number equal to itself, it will still give you the same solution. Does everyone follow that?
Yes.
All right, now B. We had 2x minus y plus 3z equals 3. Negative x plus 2y minus z equals 1. X plus y plus 2z equals 2. So when I look at this problem here, I think a good candidate to get rid of is the x's. So I would start off with the middle and the bottom one. So we have negative x plus 2y minus z equals 1. x plus y plus 2z equals 2. We add them together. These will go. You add 3y, negative z plus 2z is z, and that equals 3. So now I would take the middle and the top. So you add 2x minus y plus 3z equals 3. Negative x plus 2y minus z equals 1. And so we would try and get rid of the x's here. They have opposite signs. So the bottom here, the common multiple is 2. So we'll multiply the bottom by 2. So we add 2x minus y plus 3z equals 3. This will be negative 2x plus 4y minus 2z is equal to 2. These x's would go. This will be 3y minus z is equal to 5. So now we add 3y minus z is equal to 5. Now, we'll add these two together. This will give us 6y is equal to 8. Hold on 1 second. I think I might have, let me see, that's 3. Just make sure that I wrote everything out correct. 1, x plus y plus 2z. Okay, class, I made a little error earlier on right here with the 3z minus 2z. That's supposed to be a plus z. So this should have been plus z. So let me rewrite this again. So we should have had 3y plus z is equal to 3. 3y plus z is equal to 5. Now, if you look here, whenever you have the exact same value on one side and then different values on the other side, that lets you know that this will be inconsistent, which means there's no solution. But let's say you look at this and you don't remember this. Let's say you actually went through to solve it. So let's say we wanted to get rid of the z, multiply the bottom by negative 1. We add 3y plus z equals 3. Negative 3y minus z is equal to a negative 5. These y's and z's will go and leave 0. 3 minus 5 is a negative 2. So whenever you have a number equal to a number that's not itself, then your solution will still remain the same. It'll be inconsistent and no solution. So now that is why I did 5A and B. Now, just to show you those type of solutions. Now we go here to 6. Now, the reason why I'm doing 6 is because you have to build your formula. You have to build your formula. So we have, let me do 6A. It says you are responsible for buying parts from a wholesale distributor. 3 types of comparable switches are needed. The cost per switch is $1.20, $1.90, and $2.30. You need all 3 types and will place your order as dictated by the following facts. So first of all, let me write this off to the side. You have $1.20, you have a $1.90 switch, and then you have a $2.30 switch. Now we could label these as X, Y, and Z. So basically, these are the prices of switch X, Y, and also Z. Now, the first thing they ask you, it says you need a total of 12,000 switches in this order. So basically, they say if you take switch X plus switch Y plus switch Z, it should give you 12,000 switches. Next, it says your budget would allow an expenditure of $23,400. So it's saying if you take $1.20 times the X switches, plus $1.90 times the Y switches, plus the $2.30 times the Z switches, it should give you a total of $23,400 Well, I don't need the dollar sign. $23,400. So you don't have to write the dollar sign. Okay, next. It says you need 3 times as many of the most expensive switches as the least expensive switches. So the least expensive is X, the most expensive is Z. So what you would have here, you would need 3 times the amount of the lower switches to equal to the higher switches. So 3X is equal to Z. Now, let me show you something else here. If you notice, all of these problems have the variables on one side and a number on the other side. So even though that last statement, we will add 3 times the lower amount to equal to the higher amount, we're going to subtract Z on both sides. It'd be 3X minus Z is equal to 0. So that would be our last equation. So that would take care of A, because they asked us to write the equation here. So that would take care of A. Now we go to B. Now B states that they want us to solve this system. All right. So what I would do here is I would get rid of the Z's. So I would take X plus Y plus Z is equal to 12,000. Then I had 3X minus Z equals 0. So this would be 4X plus Y, the Z's would go, is equal to 12,000. All right, next, I would take the bottom equation with the second equation. So we have 1.20X plus 1.90Y plus 2.30Z is equal to 23,400. And then we'll have 3X minus Z equals 0. Now we need to get rid of the Z. So we'll multiply everything by negative 2.30. So you have 1.20X plus 1.90. Oh, that was supposed to be Y, not X. 1.90Y plus 2.30Z is equal to 23,400. Now, I didn't leave myself enough room, but I trust that you all will. So this would be a negative $6.90 X. And then this would be, oh, you know what? Actually, I made a little error here. I shouldn't have multiplied by a negative. I should have kept it positive because their signs were different. So then this would be a negative 2.30Z equals 0. So this would give us $8.10 X plus 1.90Y is equal to 23,400. Now, we will put this over here, 8.10X plus 1.90Y is equal to 23,400. Now, we need to get rid of one of these variables here. I would think we would get rid of the Y, because all we would have to do is multiply the top by negative 1.90. So we have, this will give us a negative 7.60X minus 1.90Y is equal to negative 1.9. I'm going to put this in a decimals. Oh, I already have that. So it'll be a negative 22,800. And then we have 8.10X plus 1.90Y is equal to 23,400. So this would give us 0.5X. The Y's will simplify out, and this will leave us 600. Divide each side by 0.5, and X is 1,200. So since X is 1,200, now the problem becomes very easy. Because if we go back up here, remember 3 times X is equal to Z. So we multiply this by 3, and our Z would be 3,600. Because 3 times X gives us what Z is. Now, we go back here, in the original equation, it says X plus Y plus Z is 12,000. So we have X and Z. So X plus Z is 4,800. Subtracted from 12,000, that'll be 7,200. And this would be our final answer. And of course, you could go back and check that. Now, I'm not really going to spend that long on 1.14 because the reason why I'm not going to spend that long on 1.14 is because we're basically using a calculator here. So if you would like to stay while I go over this, you're free, you can. But if you need to go, that's fine. I will put this on YouTube tonight for the 1.14. Okay, class, what I'm going to do, we're going to do problem 1 and problem 7. And if you have any other questions from 1.14, you can always email me or come to class on Thursday, and I will go over it with you. So now, number 1, and this is on page 138. Well, actually, I'm going to do 1, 3, and 7. Okay, number 1, we have 4x plus 3y equals -1. And then 2x minus y equals -13. They said write the augmented matrix for each system of linear equations. So basically, they want you to write this as a matrix. If you notice going down, we have 2, and then going across, we have 3. So what we would do, we would draw a matrix that accommodate 2 going down and 3 across, even across the equal sign. So we'll take the coefficients of the variables. We'll take 4, we'll take 3, we'll take 2, and the coefficient of y here is -1. And then the last number would be the number behind the equal sign, -1 and -13. And that's the augmented matrix. And this is a 2 by 3 matrix. You don't have to write the 2 by 3, but that's 2 down, 3 across. Okay, now, I said I would do number 3 as well. The reason why I'm doing number 3 is because if you look at number 3, this is a 3 by 4 matrix. 4x minus 2y plus z is equal to 15. And then we have 3x plus 2y minus 2z is equal to -4. And then we have x plus z is equal to 5. So we will have 3 going down and then 4 going across. So we'll take the coefficients, and remember they must be in the same order in order for you to write the proper matrix. So this would be 4, -2, coefficient of z is 1, equals 15. So 15 would be the last value. The second equation would be 3, 2, -2, and -4. And then finally here, we have 1, which is the coefficient of x. If you notice here, we don't have a y, so y would be 0. The coefficient of y would be 0. Then the coefficient of z would be 1, and the solution is 5. So that's how you write that matrix for problem number 3. Now, problem number, I did say I was going to do just up to 7. So you know what, I'm going to do 5, and then 7 would be the last problem. So 5, and the reason why I'm doing 5 is because 5 is the reverse of what we just did. And then we would do number 7 on the calculator. Okay, so now, this is a 2 by 3 matrix. And then what happens here is they want us to write the system of linear equations represented by the augmented matrix. It says use variables of x, y, and z where appropriate. Now we know the last number in each of these matrices is the number after the equal sign. That's the first thing. So that means we're dealing with 2 values here. So we know the 2 values would be x and y, the coefficients of x and y. So this would be 4x plus, since that 3 is positive, 3y. This right here would be 2x, and since this is negative, it would be minus 5y. And those are your two equations. Okay, now number 7. It says the given system of equations, let me write them out, 2x minus y plus 3z equals 9, and then x plus 2y minus z equals negative 3, 3x plus y plus z equals 4. Now, it says, has the following reduced row augmented matrix, use your calculator to check. Now, they give you this here. They're saying you're going to go from this to this here. And this is in your book. I haven't written anything yet that's not in your book. Okay, so you're going to go from here to here. Now, let me tell you what this means. These last digits will go after the equal sign. So it'll be equals 1, equal negative 1, equals 2. Okay, same as we did up here after the equal sign. Now, this right here where you have the 1, you know, so this is x, y, z. We got x, y, z. So it's saying that this is 1x, which is just x. So this is saying x is equal to 1 because y and z has 0 coefficients, so they're gone. So here, x is gone with 0. Y has a coefficient of 1, so we know we have y. And z has a coefficient of 0. So this is saying y is 1. Then we come down here. X has 0 coefficient, y has 0 coefficient, but z has the 1 here. So that means z is 2. So your ordered triple would be 1, negative 1, and 2. Now they tell us to check this with our calculator. So this is where we're going to check this. Now, quick question. Well, let me just not say quick question. I'm going to show you on both how to do it on Desmos and how to do it on the TI-8080 calculator. So on Desmos, what you need to do is go back to desmos.com. Now, instead of going here to Graphing Calculator, you're going to go up here to Math Tools and click the arrow. They have a matrix calculator here. So you will click on matrix. You will click on new matrix and we'll tell you here. They said edit matrix A. So this is a 2 by 2. If you do add, that'll increase your rows. So that'll be 3 down. And then we had a 3 by 4. So your columns would be 4. So this is your 3 by 4 matrix. Okay, now you're going to type in all of these coefficients that you see here. So you have 2. Let me see, let me get my keyboard. When you press enter, oh no. No, I didn't mean to do that. Okay, so we have 2, then negative 1, then we have 3, then we have 9. Then we have 1, 2, negative 1, negative 3, and then we have 3, 1, 1, and 4. Okay, so now we have our matrix. Okay, we click in this middle area here. We make sure that all these numbers line up with the coefficients. They do. And remember, X, Y, and Z must be in the proper order. We have all of that. So what you would do is click on RREF. That stands for Reduced Row Echelon Form. So you would click here, and then do you see that it's capital A? You will click on this capital A. You will close your parenthesis. And then you will press enter. Now, if you look over here, you look at this matrix here. Let me see if I could, yeah, okay, good. Oh. All right, let me see if I could just get it up. Okay. If you look at this matrix here, after it's reduced, it's the same as this matrix here. So this is how you could use your calculator to get the matrix answer. Does everyone follow that? Okay, now one of your classmates said that it seems like there's always a better way of doing things, and in a lot of times with math, there is. And you could have actually used this to solve the problems we did where we did the substitution and elimination method. You could technically use a matrix as well to solve for those problems. But let me show the TI calculator too, because some people are using the TI calculator. So I want to show that too. Now I can't promise that I'll be able to show this all the time, but I'll try and show it now. Okay, so what you would need to do here, you have to press second and then X to the -1, and then you have to go to the right to edit and press enter. Now you have to type in what type of matrix you have. This is 3 by 4. So you will hit 3, enter, and then 4, enter. And then now you would type in these values. You have 2, -1, and make sure you press enter after you put in each value. 9, and then you have 1, enter, 2, enter, -1, enter, and -3, enter. Then 3, enter, 1, enter, 1, enter, and then also 4, enter. Okay, now after you typed everything in and make sure everything is in, you'll press second in mode, and then you will go to second in matrix. Then you will go where it says math, and you will go down until you get to the RREF. Now there is a REF, but you have to do RREF. Press enter, and then press second in matrix again, press enter again, close your parenthesis, press enter, and it gives you the same values. Now that is how you would do it on the TI calculator, for those of you that are still using the TI calculator. So basically, we are done. You just need to complete problems 9 and 11, and then you will be done with 1.14. All right, thank you all. Have a wonderful night, and I will talk to you all on Thursday.